Hello, hello, hello. This is Mr. Campo, and today's lecture is going to be about surds and indices. Okay. Let's get started. Surds and indices. All right. So, check out. Okay, it's working. All right. So, clear this. Surds and indices. So what's a surd? So, a surd is basically an expression involving a radical sign in which the number inside the radical cannot be simplified any further. What do I mean by that? This one you can simplify, right? This is 4 times 2, and the square root of 4 is 2, so this becomes square root of 2. I'm sorry, 2 times the square root of 2. However, what if I have square root of 3? Can I simplify it? So that's a third. Square root of 7, square root of 2. So these are examples of surds, okay? Not only the square root, it could be a cube root, fourth root. If you get to a number where you cannot simplify the number inside the radical any further, that's it. That would be a surd, okay? And properties of these, so you probably know this stuff, but in case in case you forgot, we're gonna review them real quick. So if I have these two numbers, A and B, being greater than or equal to 0, remember that if you have them inside the radical and you're multiplying, you just bring them both inside the radical sign and you just multiply them together. If you have what I did, well, I didn't do it before. Well, if what I did before, but in reverse, if I have something like A times the square root of B, I can bring this A inside, right? And it'll be A squared times B. If I'm taking the square root of square number, this is the same as A. And if I'm dividing, so I can just separate this, right? This is the same as this. And this can help me simplify the fraction. And obviously B cannot equal to 0, okay? All right, let's do some examples. Example 1. If I have the square root of 8 minus the square root of 2. So how do I simplify this? This is not a surd. So remember, I can simplify it as 4 times 2, so 2 times the square root of 2, and then this minus the square root of 2. So again, you treat this as a, hold on, my Y is here. Pause. All right, so these two you can combine because they have the same radical surd. So this would be 2 minus 1 equals to 1, and then you just keep the same surd. And that's it. Simple, right? Number 2, let's see, we got the square root of 20 minus 2 times the square root of 45. So again, we have to simplify this, and the goal is to write everything with the same surd. So this, I think I'm gonna have a square root of 5. Let's see. So it'll be 4 times the square root of 5 minus 2 times 9 times 5. Square root of 4 times 5 minus 2 times the square root of 9 times 5. We got a 2 coming out of this. Keep the 5. A 3 comes out of that. All right, and then we have 2 times the square root of 5 minus 2 times 3 is 6. The square root of 5, and then you have the same surd. So now you can combine these two, and then you're going to get 2 minus negative 6, so that'll be negative 4. times the square root of 5. Easy, right? Okay. Just let's do it here. Number 3. 3 times the square root of 242. So 242 is the same as 121 times 2. All right, and the square root of 121 is 11, so we can just factor, well, not factor, but, take the square root of 121, and that's 11, and this would be 33 times the square root of 2. Simple, right? Okay. Number 4. So we have square root of 3 minus the square root of 9 minus the square root of 27 plus the square root of 81. So you can see that these are, you can rewrite these numbers as surds with the number 3 inside the radical. Let's see, this would be 3, this would be 9 times 3, and this would be 81. Well, obviously 9 times 9 is 81. I don't know why I was overthinking it. Square root of 81 is 9. 9 times 9 is 81. Okay, and then we have, let's see, square root of 3. We cannot combine it with anything. Well, let's simplify all of this first. Then this is going to be negative 3 and 9. So that's 6 plus 6. And then we have this minus square root of 9 is 3. All right, so this comes here, negative 9. Sorry, negative 3 and 9. That'll be positive 6. And then this we simplifies to negative 3 times the square root of 3. And then these two have the same radical, so I can combine them. So negative 3 plus 1. So that'll be 2, negative 2 times the square root of 3. Okay. Number 5. We have square root of 3 minus the square root of 2, and all of this being squared. So the same expression twice, so we have to multiply this times this. All right, so this times this will be 3. This times this would be minus the square root of 6. This will be minus the square root of 6. And then this is negative the square root of 6, and then plus 2. So we have 5. 3 and 2 is 5, and then negative 2 square root of 6. And that's it. Number 6. Square root of 5 plus 2 times the square root of 2 times the square root of 5 minus 3 times the square root of 2. Again, we have to apply the distributive property. We'll multiply this time we FOIL it. So that'll be, this will be 5. This will be negative 3 times the square root of 10. This would be plus 2 times the square root of 10. And then this would be minus 6. This would be minus 6. And then this is 2. So we have 5. This right here, negative 3 square root of 10 plus 2 times the square root of 10. That becomes negative 1. And then minus 12, right? And then we just have negative 5 and negative 12. That's going to be negative 7 minus the square root of 10. Okay. Next, it's going to be conjugate. All right. Conjugate surds. So these we use usually to rationalize denominators or simplify an expression with surds, right? So usually we use them, right, to rationalize denominators. And that's going to be the main use here for our lecture. So conjugate surds are going to look like this, just a negative. And then when you multiply them, you're going to get rid of the surd of the radical. So like, I'll give you some examples. So sometimes you're gonna get an expression like this. Sometimes you just have just a surd, a single surd, there's no plus or no sign. So that's easier to rationalize. So let's see, if we have this 5 over 2 times the square root of 3. So we don't have to do negative 2 times the square root of 3. We just multiply by the square root of 3. As you guys can see, this is just 1, right? Excuse me. So this is 5 times the square root of 3 over this 2 times 3, right? This becomes 3, so 2 times 3 times 3 is 6. And now 6 is a rational number because 6 over 1 equals 6, and 6 and 1 are integers. And remember that a rational number can be expressed as the ratio of two integers where q does not equal to 0. Okay? All right, let's do more. Now we're going to use the conjugate surd of this to rationalize it. 1 over the square root of 3 plus 5. Let me move this a little bit. Excuse me. So now we're going to multiply by the conjugate. Yeah, the conjugate. So we just same expression but negative. So square root of 3 minus 5 over square root of 3 minus 5. Okay? So the numerator is just the same, right? And then the denominator, this is like, well, let's do it so you can see. This is 3, right? This times this is 3. And then you get the square root of 3 times negative 5, and the square root of 3 times positive 5. So those two are going to cancel out, right? Let's just write it out and you see. Negative 5 the square root of 3 plus 5 times the square root of 3, and then minus 25. Okay, so we get square root of 3 minus 5 divided by, these two will cancel each other out, and then we get negative 22. And then if you want to distribute this negative, you would get 5 minus the square root of 3 divided by 22. Okay. Easy stuff, right? All right, let's do another one, a little more complicated. So we have square root of 2 plus 1 divided by the square root of 2 minus 1. So our conjugate surd would be the numerator, right? We're going to use to multiply this. Square root of 2 plus 1, square root of 2 plus 1. So this would be square root of 2 plus 1 squared. We can multiply it out. Yeah, those both answers would be okay. And this would be, if you notice, it's going to be, this is the difference of two squares, right? Sort of. Is it? Yeah, it's the difference of two squares, because look, I'll show you. This is how it's gonna simplify. It's gonna simplify to that, right? We're gonna multiply these two minus these two square minus these two square, yeah. So this would be 2. This times this is 2 minus 1, right? 1 times 1 is negative 1 times, well, minus 1 times 1 is 1, so 2 minus 1. And then this simplifies to that. This is just 1. Let's see. This would be 2, right? 2, and then this is 1, 2, so plus 2 times the square root of 2 plus 1, right? 2, 1, square root of 2, 1 square root of 2, and that's plus 1. Okay, and then you get 3 plus 2 times the square root of 2. And that would be the answer. I would accept this one too. This one is also okay. Excuse me. All right, example 3. Expresses a single fraction with rational denominator. So now they're going to give us some algebraic fractions, and we're going to have to rationalize them and then combine them. Okay, let's see. So we have to rationalize them separately and then combine them. So this would be, I'm moving my VPN out of the way. 1 times, it's too big. 2 times the square root of 3 minus 1 times. You know what I'm going to do? I'm going to bring this, I'm going to write it as a 12. Okay, it will be the same, right? I'm going to do it this way. I'm going to write, this is the same as 12, a square root of 12, right? Equals the square root of 12, right? So I'm just going to use that 1 over the square root of 12 minus 1 times square root of 12 plus 1 divided by the square root of 12 plus 1. All right, that'll be the conjugate of that, plus 3 over, and I have square root of 3 plus 1, and the conjugate would be square root of 3 minus 1. Okay, and then the numerator of this is going to be the square root of 12 plus 1 divided by, remember, this square is 12 minus the square of the the other one of this term, right? Minus the square, well, we multiply them together, so it's a square, same number, right? All right, yeah, so it's just the square of the first term minus the square of the second term, right? And then here we're going to get 3 times the square root of 3 minus 3 divided by, again, this one square is just 3 minus square root of 1 is just 1, right? I mean, the square, 1 square is just 1. All right, so we're going to get, let's see, 12 plus square root of 12 plus 1 divided by 11 plus excuse me, 3 times the square root of 3 minus 3 over 3 minus 1 is 2. I'm gonna have to use on the next page for this. or I have to erase this. I'm gonna have to draw smaller. All right, so the least common multiple is 22, right? So we can write that as 22 divided by 11 is 2, and then 2 multiplied by this, so we get 2 times the square root of 12 plus 2 plus 22 divided by 2 is 11. 11 times this would be 33, square root of 3 minus 33, right? All right, and then this will simplify to all right, and then when you combine these, come on, the whiteboard's not working well. When you combine all of these, all right, you're gonna get, when you simplify it, you should get 37 times the square root of 3 minus 31, okay? And that'll be the final answer for that. Next, example 2. I'm gonna write smaller. I think I have to write smaller because this, I don't have enough space. All right, let's see. Square root of 5 plus 2 plus the square root of 2 divided by square root of 5 minus the square root of 2 minus the square root of 5 minus the square root of 2 divided by the square root of 5 plus square root of 2. Again, you want to rationalize first and then combine. So let's rationalize these. Square root of 5 plus the square root of 2 divided, come on, divided by square root of 5 minus the square root of 2, and then I'm going to multiply by the square root of 5 plus the square root of 2, right? And then this minus square root of 5 minus the square root of 2 divided by the square root of 5 plus the square root of 2, and I multiply by the square root of 5 minus the square root of 2. Square root of 5 minus the square root of 2. Okay. I think it's going to help me. Okay. So let's see. This would be 5 minus 2, right? Square root of 2 squared is just 2. And then we're going to have this square, right? Minus, same thing, isn't it? Yeah, right. So it's the same 5, square root of 5 plus square root of 2, and square root of 5 minus square root of 2. So we should get the same 5 minus 2. And then this would be square root of 5 minus the square root of 2 squared, right? So this is 3, so we can just write it as this. And then notice that this is the difference of 2 squares, right? Minus. All right, Difference of 2 squares, so this is going to simplify to, it's going to be a long one. Square root of 5 plus the square root of 2 minus, I'm going to do plus first, plus this right here. All right, this times square root of 5 plus the square root of 2 minus this, so it'll be negative square root of 5 plus square root of 2. Let's see, what can we cancel? This 2 can cancel. This is 2 square root of 5. And then from here we can cancel this one, and we get 2 square root of 2, right? Yeah. And then this would be simplifies to 4 times the square root of 10 divided by 3. And that's it. 10 cannot be simplified any further. 5 and 2, that's not going to help us simplify that surd. So that's it, right? Okay, long one, right? All right, example 10. Not 10, 4. What did I say? I say 10. So we have, if x equals to this, find the value x plus 1 over x, and show that x squared plus 1 over x squared equals to 10. So let's see. I'm going to take care of this first. So I'm going to have square root of 3 plus the square root of 2 plus 1 over the square root of 3 plus the square root of 2. I'm going to rationalize this, okay? All right, and this would be 3, right? This times this is 3. Minus this square is just square root of 2 square is 2, right? And that's just 1, right? 3 minus 2 is just 1. And then we have square root of 3 minus the square root of 2. Okay? I don't want to confuse you. Hold on. I rationalized this and I got this, but I'm still adding these, okay? Please don't get lost. I mean, I hope I didn't confuse you. You see, I started rationalizing this right here. I did this, and now this is this term rationalized, right? But then I put an equal sign here. So what I'm going to do is I just brought these two here because I didn't do anything to them yet. And then this is just 1, right? 3 minus 2 is 1. So this simplifies to the square root of 3 minus the square root of 2 plus square root of 3 plus the square root of 2. Now these two will cancel each other out, and I'm left with 2 times square root of 3. Let me draw that better. All right. So this is the same as this. All right. Now, check this out. If I do this, right, x plus 1 over x times x plus 1 over x, I'm doing the same as this, right? 2 times the square root of 3 squared, right? Because I'm doing x plus 1 over x squared, okay? That's what I'm doing, right? And this is the same as this, right? Because this, from our previous page, these two are the same, right? This and this are the same. So if I square this, let me do it here. If I square this, it's the same as doing this, right? And then again, I can break it down into these two, right? These two expressions. And I'm going to multiply them out. So I'm going to get x squared plus 1 plus 1. This times this is x. This times this is 1. This times this, 1 over x times x is 1. And then plus 1 over x squared. And here we have 4 times square root of 3 squared is 3, right? And then we have this x squared plus 2 plus 1 over x squared equals to 12, right? Now I'm going to subtract 2 from both sides. And that's going to give me x squared. This is 0 plus 1 over x squared equals to 12 minus 2, 10. And I showed that, right? This is what they wanted me to show initially. And that's it. Example 5. Find integers P and Q if P minus the square root of Q is the same as 5 times the square root of 2 minus 4 times the square root of 3 times 3 times the square root of 2 minus 2 times the square root of 3. So I'm just gonna, I want to rewrite all of this like this. And my expression is to have a number here minus a third. So I'm gonna multiply all of these out. So I'm gonna get 15 times 2, right? And then this would be minus 10, 5 times this, that, times the square root of 6. This is minus 4 times 3 is 12 times the square root of 6. Okay, for negative 10, negative 12, and then 6. And then positive 4 times 2 is 8 times 3, right? So we get 30 minus 22, square root of 6, plus 24. Okay, then we get 54 minus 22 times the square root of 6. I can bring this 22 inside. So that's going to be 6 times. Oh, I did it here. 6 times 484. The square root of 484 is 22. And then we multiply that by 6. Is I will check that. Yeah. And then we're going to get 54 minus the square root of 2,904. All right, so this is our P minus the square root of our Q. So P is 54 and Q is 2,904. All right, and that's it, right? Pretty easy stuff. Example 6. Show that this is a rational number, okay? We got to show that this is a rational number. So first we want to rationalize these. Two minus the square root of 5 divided by 2 minus square root of 5, then minus 1. I'm going to bring that for inside the radical. So 16 times 5, 80. So this would be square root of 80 and multiply 9 times. All right, so this would have 8 minus 4. Apologize. 4 minus, yeah, this one squared. So that would be 4 minus, and then square root of 5 squared is 5. And then this one, 9 squared is 81, minus square root of 80 is squared. Square root of 80 squared is 80. So we get -1. So this becomes 4 square root of 5 minus 8. I'm going to have -1 here, and then I'm going to distribute it, right? So negative, this becomes positive 4 times the square root of 5, and this one becomes -8. And this one is just 81 minus 80 is just 1. So then we have -9 minus the square root of 80. Okay, and then so this is the same as square root of 80, right? Because it'll be 16, right? 16 inside the radical. 16 times 5 is 80. So we have the square root of 80. Then we have these two numbers are -17. And then square root of minus the square root of 8, the square root of 80. These two will cancel. And we got -17. And remember that all integers are rational numbers, right? Are rational. So this is a rational number, and that's what they asked us to do, right? To show that this is a rational number. Indeed, it is. Okay, I'm gonna stop right now. Part 2 is gonna have indices. So I'm gonna record that tomorrow morning because it's already 10:30 here, and I am very exhausted and tired. So yeah, I'll do part 2 with indices next, and that's it. Let's finish. Of our indices and Surds and Indices lecture. Okay, can I make the more options? Let's see, text nav, expand. Oh, I can make it bigger. I don't know if it's gonna record. Is it gonna show in the video? It should, right? Because this is a screen recording, so. But actually, it's too big. Can I move it? No. So I just make it smaller. That's good. That's fine. Okay, so let's see. Let's get into it. All right, indices. Where is this? A number written in the form a to the n is written in index form. Okay, right here. Index form. If n is a positive integer, then a to the n equals a times n times n times n. N factors, n times, right? So for example, if you got a to the second power, it's just a times a, right? Twice. A to the third power equals a times a times a, 3 times. That's it. Simple, right? A is called the base, and n is called the power or index. Where's this thing? I cannot find it. I need to make it bigger, I guess. Okay, yeah. All right, power of index, okay? The plural of index is indices. So all right. Moving on. Index laws. You should memorize these and review them if you have forgotten them. If you have the same base and you multiply them, you add up the exponents. If you have, if you're dividing and you have the same base, you subtract the exponents. If you have a power being raised to an index or another power, to an exponent, I meant to say, you multiply the two exponents, right? If you're the product of two elements, two numbers, two letters, being raised to a power, you distribute it. And if you're dividing, you can also distribute it. All right, a to the 0 equals to 1. Any number to the 0, it's just 1, right? Any number. It doesn't matter how big the number is. There is reciprocal. All right. A to the negative m is the same as 1 over a to the m. And again, the reciprocal, if you distribute this, a to the negative m, if you write it with a positive exponent, right, this would be b to the m over a to the m. So they just this will go to the denominator, and this b will go to the numerator. You can write a root as an index. Okay, so for example, square root of 9 is the same as 9 to the 1/2. Okay, this is too thick. And then you can break down the exponent, right? If you have, for example, 2/3, this could be written as 2 times 1/3. So you would have to square the number and then take the cube root of the number, right? All right. So let's see. Wrong pad. I was trying to use my computer's touchpad. Is that what it's called? The touch of the mouse pad. But I have to use my tablet. Okay. So let's write these in index form. So this would be a plus b to the negative 1. Right? This would be a to the negative 1 plus b to the negative 1. This right here, I need space for that. So let me just open a new page. Let me use the next one. Let's see, we have 1 over a plus b times the square root of a plus b. So let's write these. Oh, that line is crooked. Let's write this in index form. A plus b times a plus b to the 1/2. What's up with my writing on this? It's not good. And this is 2 over 2, right? 1. It's just 1, right? The power of 1. So we go ahead and same base, a plus b, and then we add up the exponents, right? So this would be 3/2. And then we just write it as in index form as like this. And voila, that's it. All right, I'm gonna use, let's see. I don't have enough space here, so I'm gonna have to use my paper and then use a new page. Select, can I pull it up? Oh, if I pull it up, that's not good. It's like annotated. Okay, so I don't have enough space. Sorry about that. For these to solve them here, so I'm gonna use my paper. I'm gonna open a new page, and then I'm gonna use my papers here. Okay, and I'll just write them. Use a different color, maybe black, and then a little thinner. Still thick, still too thick. There you go, that's better. Let's see, example 8. Let me erase this. Simplify. We got 25 to the x divided by 5. So you want to write everything with the same base, okay? So it'll be 5 squared to the x, right? And then 5 to the 1. This is 25, right? We just wrote it with the same base. It's base 5. And then we multiply 5 to the 2x. We multiply this 2 and x, divided by 5 to the 1. Same base, so we can subtract the exponents. 2x minus 1, and that's it. That's the final answer, right? Okay. No, that's fine, right? All right. Next one, B. The only thing is I cannot find the pen because it's too small. I cannot see it. All right, next one is 12. Jesus Christ, just remember it. My option. Every time I open it, it should just remember it, not ask me what I want. 12 to the, I'm using a new software, well, a different software to record this video, and it's a pain in the butt. I like the other one better. Look, you see, every time, like, no, just remember my previously chosen option. 12 to the, Jesus Christ, you gotta be kidding me. This too, man, like, why? Wow, pain in the ass. Times 2 to the 4m divided by 9. So we want to write everything in prime bases. What do I mean by that? Well, 2, 3, 5, 7, 11. All right, these numbers, you want to end up with these bases. So let's see, I can write this as 12 to the m times 12 times 2 to the 4m divided by 3 squared, right? And then this I can write as 2 2 to the 2 squared times 3 to the m, right? 4 times 3 is 12 to the m. And then 12 I can write as 2 squared times 3, right? Let me erase these so I don't confuse you. And then this 2 to the 4m divided by 3 squared. And then I want to combine, right? This would be 2 to the 2m times 3 to the m times these two will be 2 to the 4m plus 2. Hold on. Yeah. Combine these two. 2 to the 4m plus 2. And then 3. Well, we can cancel, right? Excuse me. We can cancel this 3 with one of these 3's, right? So we just get 1 3 down here. And now we can go ahead and do one more step and combine these. And this is 2 to the 6m. Two to the 6m plus 2 times 3 to the m minus 1, right? These two have the same base, so I can divide their subtract their exponents, and that'll be 3 to the m minus 1. And then this is these two have the same base, 2 to the m, 2 to the 4m plus 2, so I can add up the exponents, and that'll give me 6m plus 2. And this will be the final answer for that. Okay, next, excuse me, it's gonna be a really long one. Let's see if I can see it here. Oh yeah, C right here. I cannot see my pen. Where's the pen? Wow, C. So we're gonna do this mess. We can see that we need to write everything with the same base. So by looking at the numbers, I see that if I simplify these, I can rewrite them with base 3, okay? So that's what I'm gonna use. All right, I'm gonna rewrite everything with base 3. Because 9 I can rewrite with base 3, 81 I can rewrite with base 3, and 27 also. And that's going to help me simplify this. Okay. Where are my pages? Oh, here. All right, let's see. I want to write this. So we have 9 to the 2n minus 1 divided by 3 to the m plus 1. All of this being raised to the n times 81 to the n minus 1 being raised to n plus 1 divided by 27 to the m plus 2 being raised to n minus 1. Alright, so let's rewrite this with base 3. So we have 3 squared to the 2n minus 1 divided by this is already written with base 3, so I can go ahead and multiply these, and I get n to the n squared plus n. 3 to the 4th, is it? 3 to the fourth is 81. Yes. So I can rewrite this as 3 to the fourth. Being raised to n minus 1, and then this to the n plus 1. I'm going to have to multiply all of this. 4 times n minus 1 times n plus 1. And then 27 is 3, right? 3 to the third power. So we have this n plus 2 to the n minus 1. So what we have to do now is multiply all of these out, and then you can add them up or subtract them, right? Because we have all the same bases. This is multiplication, so if you do it from left to right, you're gonna add up the exponents. If you do it from top to bottom, you have to do division, and you're gonna have to subtract them. So let's see, we get 3 to the 4n, 2 times 2n 4n minus 2 divided by, again, still 3 to the n squared plus n times, this is 4 times, let's do it right here, 4 times n minus 1 times n plus 1. So we know that this is the difference of 2 squared, so n squared minus 1. And then we get 4n squared minus 4. And then lastly, we have same deal here. Oh no, this is not the difference of 2 squares. N plus 2, 3 times n plus 2 times n minus 1. So let's see, 3 times n plus 2 n minus 1, right? Yeah. So this would be 3 times n squared, and this is minus n plus 2n, right? N squared minus n plus 2n, so that'll be n squared plus n minus 2. And this is 3n squared plus 3n. 3n squared plus 3n minus 6. Plus 3n minus 6. All right, let me subtract them. I'm going to subtract them. 4n minus 2 minus n squared minus n times 3. 4n squared minus 4. Did I do anything wrong? I hope I didn't. Let's see. 4n squared minus 4 minus 3n squared minus 3n plus 6. So this is 4n minus 1n is 3n minus 2 minus n squared times 3 to the 4n squared minus 3n is n squared, right? And then we get negative 4 and 6 is 2, right? And then 4 n squared minus 3 n squared is 1. Negative 4 and 6 is 2. And then we got negative 3n. So we go ahead and add this up. Add them up, right? 3n, negative 3n, so 0, negative 2, positive 2, 0, negative n squared, and positive n squared, that's 0. So this would be 3 to the 0, and this equals 1. All right? Pretty long one, but it's cool, right? It's kind of cool. All right, next, exponential equations. Exponential equations, let's see. So pretty simple. You want to write everything with the same base so you can get this, right? If you get the same base on one side of the equation and the same base on the other, so you can just set the exponents equal to each other and then you solve. Usually the exponents are going to have variables, so you can go ahead and set them equal to each other and then you can solve and find the missing value. A has to be greater than 0 and A cannot equal 1. So let's see, for example, 7x equals 49. So you already know what the answer is, but if we do every step by step, we have to do this, right? Same base. So now we can set the exponents equal to each other. So x equals to 2. Very simple, right? Same principle here. We got 4 to the x equals to 1 over 8. So I can rewrite this with base 2. And that's going to be 2 to the 2x, right? Equals to 1 over 2 to the third power. And then I can bring this up and make it, write it in index form. So this is going to be 2 to the 2x equals to 2 to the negative 3, right? The same base. So now I can set the exponents equal to each other and I get x equals to negative 3 over 2. Okay. C 25 to the x minus 1 equals to 1. So without doing too much, you know that the only way this is going to equal 1, right, is if x minus 1 equals to 0, right? That's the only way. But let's just do it step by step. We can do 25 to the x times 25 to the negative 1 equals to 1. Then we can divide by this one right here, 25 to the negative 1. So we get 25x equals to 1 over 25 to the negative 1. And then we can write this in index form. Well, we can use a reciprocal. And 25 to the x equals to 25 to the 1, same base. So x must equal 1. And yeah, that's the only way to make this 0, right? 1 minus 1 is 0, and then 25 to the 0 is just 1, right? It's pretty simple. This one is a little more complicated, but still same steps. 1/4 to the x plus 2. And then equals to square root of 2 times 16 to the x. So we want to write everything with base 2. So I can do this 4, this 2 squared, and I bring it upstairs, and that'll be 2 to the negative 2, right? Times, being raised to x plus 2. And then this is 2 to the 1/2, and this is 2 to the 4th, right? Yeah, 2 to the 4th times 2 to the fourth time to the x is just 2 to the 4x. I can go ahead and combine these and I get 2 to the negative 2x minus 4 equals to 2 to the 4x plus 1/2. Same base, so I can set the exponents equal to each other and solve for x. So I get negative 2x minus 4 equals to 4x plus 1/2. Isolate that x. Where's I lose it? Negative 4x plus 4 plus 4. No. All right, so I see this cancels out. This is negative 6x. 0 equals to, this is 0 and then 4.5. So x equals to 9 over negative 6. And that's it, right? And that'll be x equals to 3 over 2. Negative 3 over 2, my bad. Where is this pen? I lose it. I cannot find it. Because the tip is so small. See something. All right, let me stop the video right now and I will do part 2 with the remainder problems, okay? So this is, all right, welcome to part 2 of the indices lecture. So let's continue, let's finish up. Oh, I have to edit the video. So we are doing example 9D. And we have, oh no, we finished this one. Yeah, we did it. We got x equals to negative 3 over 2, right? And if you want to double check the answer you get, all you have to do is plug it in, right? Plug it in the original expression. So you take this x and you plug it in here. 1/4 over x plus 2 equals to the square root of 2 times 16 to the x. So you just plug it in and you should get a true statement. You should get the same number on this side as on the other side. Okay, other equations, example 10. Let's solve these. X to the 1/3 equals to 2. So we have to, again, our goal is to make the exponent or the index of the x variable. We have to make it a 1, right? So in order for us to do that, we would have to raise, have to cube all of this, right? By doing that, you see this exponent index is going to become, or exponent, it's the same thing. Exponent is the same as an index, right? So this will become 1. So we're going to have our x isolated with exponent or index 1. And then 2 to the 2 cubed to the 2 to the 3rd power equals to 8. So that's it, right? Okay, B, we only have a few more. We got 2 more examples and then we finish this lecture. And then our next lecture is going to be quadratic equations, okay? So B, it says x to the negative 2/3 equals to 16. So again, we have to do the same. We have to raise this side and this side to a power so that this can become 1. So that'll be this negative reciprocal, right? This will be cancel, become 1, negative and negative is positive. And then we have to do the same here to the negative 3 over 2. So 16 to the negative 3 over 2. So this will become x. And now with this, you have to be careful, right? Because we can break this down. This negative 3/2 is the same as 1/2 times negative 3. And this means the square root, and the square root has 2 roots, right? Square root, you get plus or minus, right? So let's see, we can do square root of 16. That'll be plus or minus. Let me erase this a little bit, make it more organized. Plus or minus the square root of 16, and we are raising that to the negative 3rd power, right? In other words, this is how I broke it down. I applied this 1/2 to the 16. I raised 16 to the 1/2, and that's the same as taking the square root of that number. And then have that negative 3, so I'm gonna have to factor that in. So we're gonna have 2 answers, right? We're gonna have positive 4 to the negative 3 and negative 4 to the negative 3, right? All right, let me erase this right here. So the 2 answers would be this one, the positive one would be 0.0156. And the other one will be the same number, but negative, okay? 0.156. And these are the 2 answers. So if you want to double check, you can go ahead and plug these in. And if you get 16, that should be the right answer, right? Okay, let's do our 2 more examples to finish this lecture. Well, actually 1 more, that's it. So example 6, excuse me. So now we have x to the negative 2/3 equals to 16 to the negative 1/6 times 9 to the 1/3. Once again, remember that we have positive or plus or minus, right? Positive or negative. So you have 2 answers, right? If you use the square root. If using the square root. In this case, I'm going to do the same. I'm going to raise all of this to the negative reciprocal, right? So that's going to be negative 2/3 raised to the negative 3 over 2 equals, and I have to do the same to every other element in the expression term. I mean, every other term. Raise it to the negative 3 over 2 times 9 to the 1/3 raised to the negative 3 over 2. This simplifies to x to the 1st power, right? And then let's see, 16 to the positive 3 over 12, right? Positive 3 over 12. And then the 3 is 1, 2, there's 4, right? All right, so this would be to the 1/4. And then this would be 9 to the negative 1/2. Right? Okay, so all right, so from here we're gonna get this actually. We're gonna get the 4th root of 16 is gonna be positive and negative 2.
And this 9 to the negative 1/2 is going to be 1 over plus or minus 3. All right. So we're going to get either 2/3 or negative 2/3. Okay. If you multiply all the possible options, choices, you get these two, positive and negative 2/3. So these are the answers. Okay. X can be 2/3 or negative 2/3. Okay. All right. And that's it for this video. If you are one of my students, please remember the homework, right? Homework, learning guide 0-3 and 0-4. If you have any questions, remember, drop them in the comment section. If you're one of my students, send me a message via WeChat, okay? Let me write WeChat, all fancy. WeChat. Nice. All right. Thanks for watching, and I will talk to you guys later. Bye-bye. Take care, Satyan.